6.25. Two inclined frictionless tracks, one gradual and the other steep, meet at A, from where two stones are allowed to slide down from rest, one on each track, as shown in the figure. Will the stones reach the bottom at the same time? Will they reach there with the same speed? Explain. Given that theta 1 equal to 30 degree and theta 2 that is 60 degree and height h that is 10 meter. What are the speeds and times taken by the two stones? See here, from A, these two stones are released. So we already discussed the object on the inclined plane. So when any object is placed on the inclined plane, then parallel to the slope or parallel to the inclination, the force that is mg sine theta. So if we consider the stone 1, which one is moving on this left hand side, having the angle of inclination theta 1 equal to 30, for that the force parallel to the slope that is m1g sine theta 1. Similarly, for stone 2, we can write the force that is m2g sine theta 2. Now force that is mass into acceleration. So acceleration of stone 1 that is g sine theta 1 and of 2 that is g sine theta 2, but g and theta both are constant. So we can say the stones are moving with constant acceleration. Now suppose the length of the slope here on left hand side that is d1 and time taken by stone to reach the bottom is t1. On right hand side the length of the slope is d2 and time taken by the stone 2 to reach the bottom is t2. Then we can use the equation d equal to v0t plus half at square. Initial velocity of both that is 0. So we can use the equation d equal to half at square. So d1, this distance, that is half, acceleration is g sine theta 1, g sine theta 1 into time taken by it is t1, so t1 square. Now similarly we can write here d2 that is half g sine theta 2 t2 square. But see, sine theta that is opposite upon hypotenuse. So hypo that is opposite upon sine. So we can write d1 that is h upon sine theta 1. That is equal to half g sine theta 1 t1 square. We want to calculate time. So t1 square equal to 2h upon g sine square theta 1. Similar to this one, we can write the equation for stone 2. Time taken t2. So t2 square equal to 2h upon g sine square theta 2. Substitute the values 2. H is 10, g 10, sine 30 square. And when you solve this one, you will get t1 that is 2 root 2 second. And here substitute 2 into 10 upon g10 sine 60 whole square. You will get 2 root 2 by 3. So we can see here time t2 that is less than t1. Clear? So will the stones reach the bottom at the same time? No. Clear? This second stone will reach earlier compared to the first one. Okay. Now we want to calculate the speed. See, here both are released from the height h. When first one reaches at the bottom, suppose its speed is v1 and for second one at the bottom that is v2. So when the stone reaches at the bottom, entire potential energy will be converted into kinetic energy. So we can write when stone reaches to the bottom, kinetic energy, that is the potential energy. So half m1 v1 square equal to m1 gh for stone 1 we can write, and half m2 v2 square equal to m2 gh for stone 2. So we can write v1 square equal to 2gh and v2 square equal to 2gh, means both the velocities are same one. So both the stones will reach at the bottom with same speed, and that same speed is, so we can write now v1 equal to v2, say it is v, so that will be under root 2gh, 2 g10 h10. So answer is 10 root 2, means both the stone will reach at the bottom with the same speed equal to 10 root 2 meter per second.